Hello, welcome to our next episode of Astroviews, where we interview really interesting people about space, about astronomy, about science, about all the things that they love. And today I'm really excited to have one of my favorite people, who's probably going to be one of my favorite guests. This is Jesse Rogerson. Hey, Jesse, how you doing, bud?
Hi there. So I'm supposed to be an interesting person, is what you're saying.
Well, that's on you over the next half an hour. that's really I invited you on here assuming that you would bring something interesting. So let's hope that
only time will tell.
Yeah, let's hope that you can live up to that. So why don't you start by telling the lovely people here who you are and what you do that's related to space.
All right. So I'm an assistant professor at York University. I teach a variety of courses. One of them is Introduction to Astronomy. I'll be teaching history of astronomy. I teach planetary sciences. I come from the museum world, so I've been working in museums and science centers for the last 4 or 5 years. And before that, I did a PhD in astrophysics. So I have quite a long background in astronomy. I started in undergrad, and I basically didn't stop studying space until, well, I haven't stopped yet. So I study space, I teach about space, I work with museums, I do science communication and education public outreach. And yeah, that's like who I am in a nutshell.
You've reached the highest level of education in our field.
Yeah, well, kind of. It depends on how you look at it, because a PhD is like the sort of the highest formal education you can get. But then after that, the next step would be a postdoctoral fellowship, which is still kind of like an education. I mean, you're basically working as a scientist, but you're still learning as you go. And I don't think it really stops until you're really like a full professor, like a full researching professor, which I'm not. I'm a teaching professor. A researching professor is someone who continually does their research and builds their knowledge. So in terms of formal education, yes, but in terms of ongoing education, I don't think astronomers are ever really done. I think they just keep going and keep learning as they research.
And that's a good thing for a scientist, is to always, if you're a researcher professionally, a professional scientist, you're always searching for the truth. You're always searching for the answer to the next question that you ask.
There's always another question. And when you spend a few years doing a research project and you get some really cool results, it's going to inevitably lead you to the next question or to something else that you don't understand or something that you could do better. That's the point of the science. That's the point of the job, is to just keep looking for more answers. The natural world is so complicated, and we've learned so much over the last few thousand years as humans. But there's always, like, there's still so many big questions, and there's still so many things we don't understand, and interrelationships we don't get. The job is never done. The scientist's job is never done.
So we're asking lots of questions as we learn more about the universe, but what was the first space question that you ever asked? I guess the question would be, what led you into astronomy and space? What inspired you to start pursuing astronomy and space?
It's funny. So I never meant to be an astronomer. When I was going through undergrad, when I started undergrad, I was doing computer science, and I took an elective course. My elective course was astronomy, and it really did sway me into astronomy. So the course in general was what swayed me, but I remember a moment and Ryan, you were in that class, where it was with Ralph Pudritz's McMaster University, and I can't remember what led us up to it. We were doing something about gravity, and we worked out in class, the gravitational effect of all the planets lining up on Earth. So like if we were on Earth and all the planets were lined up in a line, would we feel any tidal forces related to that, all the gravity working in one line? And we wouldn't. And I remember being just blown away by like, we can just use these like simple formula that Newton came up with back in the 1600s, 1700s. We can use these simple formulas and we can make such a grand prediction about our solar system. And that sort of was like hook, line, and sinker. I'm like, I'm in. Tell me more about space. I can use a formula and I can figure things out. Let's do it. That's the moment I remember. But the whole course in general was really like that. We did a whole bunch of stuff in undergrad that really pulled me in. And by the time I was done undergrad, I just couldn't let go. So that's why I went into grad school, and that's why a master's started and a PhD started, and here I am today, because the foundation from the undergrad, from that first course in first year, really pulled me in.
So now we get you kind of through your career into astronomy and space. You're in the midst of a really great career in astronomy and space. What career goals do you have? I know you just started working at York, but what goals do you have for the future in this job and beyond?
Okay, so I have so many goals. I have I have too many goals to list, which is a good and bad because I need to prioritize. But I digress. So in terms of the main goal of my job, I just starting at York as an assistant professor. It's teaching stream. So my job is to teach science to non-science majors. What that means is my entire teaching portfolio will be about trying to get people who are not in a science faculty to understand the process of science, the meaning of science, and how we carry it out, what it means when we get an answer, how we do the next steps. My real goal is not just to give them a cool science experience, but that to inform a public that goes out into a world, into a non-science career, what science really is. Because science is portrayed in the media, in the blogosphere, on social media, as a very different thing than what it actually is. And science is a grind. Science is an engine. Science is a constant rolling, moving forward engine that slowly figures things out and is wrong sometimes, but figures those things out. And that process of learning and retesting and re-asking and retesting and learning and going backwards 3 steps to figure out where you went wrong, that whole idea of how science moves forward and uncovers truths is a really important part of the human experience, especially nowadays. It's really important. So that's my goal in terms of the York classroom experience.
You're teaching first-year students as well, so you're really getting students who are fresh out of high school, who have wildly different backgrounds in education in science, and trying to drive these foundational ideas of here's what you need to know to be a scientist, or even just to be a good citizen. Here's what we're going to learn.
And that's the thing, is that all the people I'll be teaching are not planning to go at the moment to a science career. So they're going to other things. They're going to be lawyers. They're going to be mechanics. They're going to be art, history. They're going to work in museums. They're going to work in cultural institutions. They're going to start their own businesses. They're going to do all these wonderful things. And they, as a result, they won't be steeped in a science filter the way you and I do all day. But they still have to help make decisions. They still have to vote. They still have to help make decisions about how we move forward as a society. And a lot of those decisions, or at least some of those decisions, should be based in science. And they need to understand how we get to those answers. They need to understand how the scientists collect their data and why they're asking those questions and why things change when new data arises. These are all really important things for an informed citizenry to have. And even though you and I sit in science all the time, we need to flex those muscles just as much as everybody else does. So we need to continually relearn how to think through that filter, to continually relearn how to ask the right questions and look at the right answers. It's something you can never turn off. You have to always be thinking about it. And if I can just get that into them a little bit, impress upon them the process of science and why we use it, I think that goal will be achieved.
So that's a good short-term goal now that you're starting a new job. But for the long term, after this year, after next year, after 5 years, after 10 years, what's the next stage? What's the final stage? I know you can't really see anything. You don't have a crystal ball, but where would you like to end up someday?
I want to, on almost like a personal note, I want to do cool things and see cool stuff. So I want to use big telescopes. I want to go to cool places. So I want to use my career to use to ask big questions in space and use those big telescopes to try and solve those questions, which I'm still doing, sort of continuing my PhD work. But in a sort of the most grand of goal would be to engage with as many people as possible about space and science. So whether this be in the classroom, whether this be through social media, or just participating in in-person events when we can do in-person events again. So these would be like town hall discussions or presentations or going to clubs or working with younger kids in the community. Trying to be as engaging as possible to as many people as possible is the overarching goal of the career, I think.
That's a great goal. And it's nice to have something that's broad enough that whatever comes your way, whatever choices you have to make, whatever opportunities you get, you have that lens to kind of decide, this is where I want to go with this.
And for all those people out there that are listening, that's why you make goals. You have that overarching goal, and then you have little sub goals, and then you just, when opportunities come your way, you can be like, you can kick them out of the way, or you can pull them in, depending on the how they align with the goals. Just the filter, like you're saying, right?
A little bit more on the fun aspect of things. What is your favorite celestial object and why?
Right. Okay. This is a tough question. So, thinking about it, there's so many cool things out in space that are weird and crazy, but I honestly think that the moon is my favorite. It's simple, but I think that's the beauty of it. It's right there. Everybody can see it. You don't need a telescope. You don't even have to be in a dark sky. You could be in the most light polluted sky on the planet, and the moon will be right there for you to see on a clear night. You can see it no problem, and it leads to so many great questions. Like when the moon is a different color, you can easily dive into a cool conversation about the atmosphere. Or when the moon is a different shape, you can dive into a cool conversation about how it moves around the Earth. Or when we can't see the moon, you can dive into that question as well. And if you get lucky enough to see like a lunar eclipse or something like that, there's so many cool entry points into how our close solar system works, the Earth, the sun, and the moon, and how that all works together. It's such a simple thing to just put out a lawn chair, sit back with some friends, and look up at the night sky and see the moon and just chat about it. And I think just on the surface of it, I would go with the moon. I think it's my favorite object up there. It's easy to see. It's fun to talk about. It's a good entry point.
That's good. I like the moon. How can you not?
How can you not, right? It's amazing.
It is most people's first celestial object that they ever see.
Yeah.
And sadly for some, it might be the only celestial object they really observe. But
yeah, if you live in downtown Toronto or New York or LA or Shanghai or any huge Tokyo, you see at best a few stars on a clear night, but the moon will always be there, and it's a good entry point. Now, don't get me wrong, there's a lot of cool things. There's a lot of cool galaxies to check out, some incredible nebulae to check out, and in some of my research, there's some top cool objects like the quasar SDSS J023011 was a really, really cool object. But I think at the end of the day, I gotta go with the moon. It's the coolest one to talk to with people about.
So one of the things that we often learn in science is where things came from, where these great ideas started out in history, how things evolved, how scientists stood upon the shoulders of those who came before them. So if you had any scientist living or previously living throughout history that you could sit and have a 1-hour lunch with, who would that be?
This is such a hard question. There's so many scientists out there. I honestly don't even know where to start. Like, do I start in astronomy, or do I only stay in astronomy? I mean, that's my favorite, but there's so many cool sciences like paleontology or like neuroscience or like the study of genetics. I feel like there's too many to really make a good informed choice. So I fall back on a scientist that I really enjoy telling stories about, and that is Henrietta Leavitt. And I say for a couple of things. One, Henrietta Leavitt was the scientist who helped establish the period luminosity relationship for Cepheid variables. This was in the early 1910s, so like I'm not even 100% sure on the date, 11, 12, 13, something like that. So she was the scientist who established that relationship. Super important because it helped us it helped us start measuring distances further out into the universe, which completely opened up our universe for us to understand exactly what is a galaxy, what's contained within a galaxy, and what's beyond our galaxy, the Milky Way, and that there are other galaxies. And this work was built upon, and Hubble built upon it, and really solidified that whole thing, along with a multitude of other scientists. But Henrietta Leavitt, the reason I choose her is because she was a female scientist in a time, and I say in a time because it's still a thing where women or people of color are scientists who are underrepresented, pushed out of academics, but still do such incredible things, persevere beyond belief, and an experience that I don't have in any way, an experience that I don't understand. So if I were to really think about it, I want to speak to someone like her, someone who made an incredible impact on the field of astronomy by figuring out that relationship in a time where it must have been incredibly hard to do so. And just to understand her experience and to learn from it and to try and internalize that and see through my own worldview how I can change, how I can pull that in. And the beauty about that is that I could probably find I can definitely find scientists now that can give me that same experience and learn about that same experience. But if I'm going with the living or previously living, I'll go with Henrietta Leavitt. Such an important part of astronomy with a really incredible experience to share. It sucked to only have the hour with her, though, that's for sure.
Okay, so you're having lunch with Henrietta Swan Leavitt. What would you ask her?
Oh my gosh. I would ask her, you know what I would ask her is like, how did you get into astronomy? The questions that you're asking me, I'd be like, what got you started? Where did you start? Why do you do it now? I'd be really interested in hearing, because this period luminosity relationship is so important, I'd be interested to hear the thought process as she was going through it. I'm like, okay, collecting the data, measuring the brightnesses, the magnitudes of all these stars, measuring their periods, charting it, and just the whole process. Like, did she feel like she was making a huge impact at the time, or did it feel like just another research project? Did it feel big, contributing to something like that? I imagine that it did. I'm sure that she knew what she was building towards. But when you're in the middle of it, when you're in the middle of the work and you're doing all the little fine details, maybe you don't think about it as much. I don't know. It'd be interesting to hear how she was feeling, helping make that such a large contribution to astronomy.
Now that you've gone through years and years and years of education,
so many years.
Yeah, right. We could go back and recount them all, but a lot of years, more than most. You've gone through all this education. You've learned a lot. You are an astronomer. You are a professor, an assistant professor, but a professor. What advice would you have for the next generation coming up? What advice would you have for somebody who wants to be an astronomer, be a scientist, or just pursue something to do with space?
So I can only speak from my own experience, things that helped me, but some. So as I said earlier, when I started university, like, I was going for computer science. I liked coding. I learned in high school that I really liked coding, and I also learned that I really liked physics, but I was so sure that I wanted to be a computer scientist. So I went to university to attempt to be that, but I really learned really quickly in university. The high school experience was very different from the university experience, and whatever it was, it left a bad taste in my mouth. Astronomy was way more interesting to me than computer science in university, and I felt like I chose astronomy because I was so interested in it that it made me do the things I didn't like. So mathematics is the language of physics, and physics is astrophysics. So in order to do astronomy, to do our degrees that we did, we did so many math courses. I can't remember how many math courses we did, but it was a lot. And math was honestly never my best subject. I always had to work hard to get good grades in math. I did much better in physics courses. Physics made sense to me. I still had to work. Of course I had to work. But physics felt more natural. But when you're doing math, like when you're doing a linear algebra course or a calculus course or a partial differential equations, or the list goes on, it felt horrible. I hated doing them. I did not like doing math courses. But I did it. And I did it because I wanted to be an astronomer. So the pieces of advice that I would give is that don't be afraid to chase the thing you want. I wanted to be an astronomer. I had no idea what kind of career I could get out of it. Astronomy was looking at the night sky. I didn't know what I could turn that into, but I did it because I wanted to do it, because I was interested in it. And the other thing is that even though it's the most interesting thing that you choose, there's going to be stuff that is hard or difficult or challenging or annoying, but grit your teeth and get through it, because that stuff is short term, but the stuff you get out of it is long term. You get a cool career that you really want to do, and you'll find that it's sort of the stuff that makes it worth it almost. The hard work is the stuff that makes it pay off. Don't be afraid to make a change for something that you really want, and get through those crappy nights of studying, because there's some cool stuff that you get to do afterwards.
Nice. So we've got some advice going. Now we're going to get into some of the philosophical stuff, some of the stuff that you...
Okay.
I like to ask people who are in the space and astronomy world to get their opinion, their ideas of it. What's the next big discovery in astronomy or space science in the next, we'll say, 50 years?
This is a tough... I say this every time you ask a question. This is a tough question. There are some big questions in space right now. The two darks are really important. Dark matter and dark energy are big ones. There is the origin of life, or even if there is other life elsewhere. And you know what? What's a really fascinating one? Okay, here's the one I'm going to go. Here's the one answer I'm going to give. I think with the Event Horizon Telescope, which has come online in the last couple of years and did some really good work with M87 and our own Sagittarius A star. These are supermassive black holes at the centers of galaxies. So the Event Horizon Telescope was designed to resolve the event horizon around a supermassive black hole, the point at which the closest you can get to a black hole before light can't escape anymore. So really to resolve the region that a black hole takes up. That has never been done before, and they did it over the last couple of years. And some really cool pictures online. You can go Google M87 supermassive black hole. There's some really great pictures with that telescope, and with it getting better, with them calibrating it better, with them doing more and more work with that telescope, which is a conglomeration of radio telescopes around the world. They're going to get an even better view of the event horizon. So imagine being able to resolve even better the event horizon. And I think that there is some potential there to learn more about what's going on inside the event horizon of a black hole, the region we can't see. Now, we'll never get light out of that because physics demands that light cannot come out of it. But being able to resolve the event horizon, to see what the physics is going on at the edge of the unknown, really pushes boundaries we don't know about. And so what I'm leaning towards here is that I think we'll be able to put at least some bridges between quantum physics and general relativity in the next 50 years to help us understand what a black hole really is and how it works at its core. Because people always ask that question, what's going on inside of a black hole? We have some ideas, but we can't really figure it out because that boundary is where things are really small and gravity is really strong. And the relationship between quantum physics and general relativity, which govern those two realms, it's tenuous, and we don't really know how they talk to each other. The Event Horizon Telescope, just the cool image that it created, super awesome, but the data that it's going to pull down on all the black holes that it can get its hands on, I think it's going to really open our eyes to what a black hole is. So I'm going to go with that. Next 50 years, that might even be sooner. That's like the next 10 years. We'll have a better sense of what a black hole is and how quantum physics and general relativity work.
Being an astronomer and always looking into the universe, looking up into space, do you want to go there? Would you go to space given the chance?
Absolutely, I would, 100%. I still haven't ruled it out. I think, it's one of those things. It's like you say, when I grow up, I want to be an astronaut. I kind of like still have that mentality in my head, like, oh, when I grow up, I want to be an astronaut, even though I'm already grown up and something completely different. I'm hoping that space becomes so accessible in my lifetime that I get a chance to do it. I'm not sure if that will be the case. There is the possibility with companies like SpaceX and Blue Origin and Virgin Galactic. There is the possibility that if I somehow win the lottery, I might be able to buy my way on a trip to space. So I would always jump at the opportunity. Although my partner, I don't think she would be a huge fan of me doing it. But yes, 100%, I would go. I would go to space. I would go to the moon. I would go to Mars. Wherever I could go, I would go.
You mean Alex doesn't want you going off into this dark, frigid vacuum where there's no air and everything can kill you?
This super dangerous trip on top of a rocket with so much fuel and into a completely dangerous place. Yeah, I don't think she'd be a huge fan of that.
Yeah, I'm just going to ride an explosion into this empty, cold endless death.
Yeah, but imagine how cool it would be. Imagine walking around on the moon. I would totally do that.
So then on that note, walking on the moon, the next step is probably Mars. When will the first human walk on Mars?
When will the first human walk on Mars? Okay, well, let's look at NASA's plan. So NASA says, if we go by NASA's plan, NASA says 2024, they're going to be back at the moon. I don't know if that means people on the ground, but that definitely means a working space station and robots going to the ground, on going to the lunar surface. So that's 2024, 2025. If that sticks, I think that within 10 years after that, that you could see humans on Mars. So something like the mid-2030s, I would bet we would see humans walking around on the surface of Mars. At least that's my hope. That's following timelines from NASA and other space agencies, and that's hoping that they stick to their schedules. Schedules can definitely be delayed, as we've seen with so many different space missions. And you could also have the monkey wrench thrown in the gears by companies like SpaceX, where SpaceX doesn't really follow anybody's rules. They do their own thing. So it's possible that SpaceX could reach it before NASA or do it in collaboration with NASA and accelerate the program. So I think a best case scenario based on what I know would be like the mid-2030s, which is exciting because that's like quite easily within our lifetime, which means we're going to get to watch a human walk around on Mars, which would be just the best thing ever.
That would be. Okay, one last question with the last few minutes that we have. Is there life in the universe?
Is there life in the universe? Yes, probably. I can't say for certain because we have no evidence to suggest it. But I can definitely tell you that it doesn't make sense that the conditions here are the only place in the universe that has these conditions. We know that there are thousands of planets out there. We've already found them, and we can estimate that there are millions or billions of planets out there, and around probably sun-like stars. There's no reason to believe that there wouldn't be conditions elsewhere in the universe that's good for life. There might even be other conditions here in our own solar system that are good for life, like at places, even at Mars. Could be underground at Mars in aquifers. It could be at Europa. It could be at Enceladus. I would bet that there's life in the universe. Finding it is going to be a difficult thing. And we have so many great things coming online in the next few years, like the James Webb Space Telescope launching. There's missions going to the moon and Mars. There's tests looking at other planets. Like the science community, the astronomy community, the planetary science community is building towards answering this question. I can't imagine that I'm sure that they will find something eventually. I don't know when, and I have no evidence to back that up, but my gut says that there's life out there.
Amazing. Well, thanks for being a guest on the show, Jesse. This is going to be a lot of fun. I'm excited to have this air. if somebody wants to continue the conversation with you, how would they find you?
Oh, yeah. The best way to find me is on Twitter. I'm on Twitter all the time. It's just my name at Jesse Rogerson. And send me a tweet and ask me a question or chat or tell me what you think about life in the universe. Let's talk. I love talking about space.
Amazing. Well, thanks for joining us. This was a lot of fun.
Anytime. Invite me back.
Yeah, definitely. That concludes this episode of Astroviews. A special thanks to Jesse Rogerson for joining us. And we'll be churning them out as long as I have lots of great, exciting people to talk to. And I have a lot. So hope to see you again soon. Thanks for tuning in. People think that it can be very difficult to do astronomy without a telescope or without binoculars or without this expensive equipment. But really, all you need is your eyes and your curious mind. And to help that, Astronomy in Action has come up with our own space club. And this isn't a space club where you need a telescope or binoculars or to stay up all night. In partnership with slew.com, we give you access to remote telescopes all over the world so that when you feel the time is right, you can pop online and look through one of their huge telescopes that they have in these perfectly clear dark sky sites around the world. You can take your own images, learn about different objects through quests and challenges, and have a lot of fun as part of our community. If you'd like to join, go to astronomyinaction.com/spaceclub. We hope to see you there.